to answer question 5, lipolysis is a 5-step process, which is mobilization, transportation, activation, translocation, and oxidation. The goal of lipolysis is to convert triglycerides into ACOA, to then travel into the Krebs cycle and make ATP. So when we exercise, we induce the release of hormones like epinephrine, norepinephrine, which are more high intensity, and cortisol and growth hormones when it's more low intensity. The hormones are released into the bloodstream and meet an adipocyte that has receptors that can bind to the specific hormones. In this, hormone-sensitive lipase is released and does our first step, which is mobilization, where our hormone-sensitive lipase is there to break down our triglyceride molecule into 3 fatty acids. And the transport cellular uptake is where the fatty acids can't travel to the bloodstream alone and need to have albumin to carry them. And albumin can carry up to 7 free fatty acids at a time. As you can see here, as our fatty acid was being broken down, is now in the bloodstream attached to our albumin, which is the protein that's transporting them. And then as our albumin is traveling towards this skeletal muscle, is where they meet the sarcolemma fatty acid binding protein, which moves free fatty acid into the muscle. In this, the sarcolemma fatty acid binding protein only allows about 15% of the free fatty acids into the muscle, just to regulate. And with our third phase or step, we have the activation, which is our free fatty acid is being added to our coenzyme A, where ATP is then broken down, releasing energy for ACOA synthesis, leaving us with a fatty acid ACOA. In this, we now have our translocation, where our now made FCOA molecule is being transported by creatine transferase into the mitochondria. And for our 5th and final phase, we have our oxidation and beta oxidation, and this is where we are wanting to basically cut up FACOA and cut it up into ACOA. So here we have our molecule and our beta oxidation, so you're basically cutting it into 2. So we have 2 has been cut from the 6 molecules, and here we have our first ACOA, which will go directly through the Krebs cycle. And then we have to do another beta oxidation in order to create 2 more ACOA, which will end up going to the Krebs cycle, allowing us to make ATP in the future.